Bagustong Mark Leonard C. from the SME4. So this is my answer for number 1. The givens are K is equal to 1.34. The RK is equal to 5. The initial volume is equal to 6 cubic feet. The initial pressure is equal to 13.75. And then the temperature 1 is equal to 100 degree Fahrenheit. So you have to make the temperature a standard form. So you have to add 460 to make it a Rankine. 560 Rankine. Next is the heat Q is equal to 340 BTU. So first one is for finding the clearance. So the formula that you will use for this problem is the RK is equal to 1 plus C over C. Then you have to substitute all data. So RK is equal to 5, 1 plus C over C. So from this you will get 5C is equal to 1 plus C, and then 5C minus C is equal to 1. So it is equal to 4C is equal to 1. Then the clearance is equal to 1 over 4, which is equal to 0.25. So to make it a percentage, you have to multiply it by 100%, and you will get a clearance of 25%. So the next one is getting the temperature before the expansion. So first you have to get the T2. So the formula in getting the T2 is T2 is equal to T1 RK raised to K minus 1. So from this you will get 560 degree Rankine multiplied by 5 raised to 1.34, which is the K minus 1. So this is equal to 916 degree Rankine. There. So the next one, before you can get the expansion ratio, the temperature before the expansion ratio, you should get the constant volume, which is constant volume is equal to R over K minus 1. So the R of an air is 53.3, and the K is 1.34 minus 1. So from this you will get 53.3 over 1.34 minus 1 is equal to 156.765. 156.765. So when you find the CV, you can substitute it from the formula, which is Q is equal to MCV negative MCV T3 minus T2. but the mass isn't given, so you have to find the mass by using the ideal gas law. So pressure 1 volume 1 is equal to mRT1. So you have to substitute all the data again, which is 13.75 psi times the initial volume, which is 6 cubic feet, and you have to make it an inch. So 1 foot is equal to 12 inch cube. Using the ideal gas law, you will substitute the pressure 1, which is 13.75 pound per square inch, and you have to make it a foot. So 144 square inch per foot square foot is equal to the mass times the R and then the temperature. So from this you will get an answer of 13.75 times 144 is equal to the mass times 53.3 times 560. You will get a mass of 0.3980 pound. Then next one is finding the T3. So from this formula you can derive the equation. So T3 is equal to from this you will write Q, which is 340 times 778 feet pound over 1 BTU to make it a feet pound, and minus equal to 0.3980 pound multiplied by 156.7647 times T3 minus 967.92 degree Rankine. So from this equation you will get the answer T3 is equal to 340 multiplied by 778 is equal to 0.3980 times 156.76 47 times the T3 minus 967.916. So you will get a temperature 3 is equal to 5,207.538 degree Rankine. So this is the temperature before the expansion. So next one is finding the pressure before the expansion. So first one is using this formula, T2 over T1 is equal to P2 over P1 raised to K minus 1 over K. So you have to substitute all the data here, which is 967.92 degree Rankine over 560 degree Rankine is equal to P2 over 13.75 raised to 1.34 minus 1 over 1.34. So from this equation, you can get the pressure 2. 967.92 over 560 is equal to the pressure 2 over 13.75 raised to 1.34 minus 1 over 1.34 is equal to P2 is equal to 118.83 psi. So the next one is finding the P3. So by using this equation, P3 over P2 is equal to T3 over T2. You will find the P3 by substituting all the data again. So P3 over 118.83 psi is equal to temperature 3, which is 5,210.73 degree Rankine over the temperature 2, which is 967.92 degree Rankine. So from this equation, you will get the pressure 3 is equal to P3 over 118.83 is equal to 5,210.73 over 967.92. So P3 is equal to 639.71 psi. So you have found the temperature 3 and the pressure 3 before the expansion. Temperature before the expansion is equal to 5,210 degree Rankine, and the pressure 3 just before the expansion is 639.71 psi. The next one is finding the efficiency of the engine. So by using the formula E is equal to 1 minus 1 over RK over raised to K minus 1, you will find the efficiency is equal to 1 minus 1 over 5 raised to 1.34 minus 1. So from this, you will get the efficiency is equal to 1 minus 1 over 5 raised to 1.34 minus 1 is equal to 0.400 0.4214. So by multiplying 100%, you will get 42.14%. So that is the efficiency of the auto engine. So the last one is finding the mean pressure. So here you will get the mean pressure by using this formula. E is equal to work over Q. So work is equal, you have to find the work. Work is equal to E raised times Q. So it is equal to E, which is 0.4214 times 340 BTU times 778 to make it a pound feet. So we can get the work from this, which is equal to 0.4214 times 340 times 778. It is equal to 111,468.728 feet pound. So the formula of the mean pressure is equal to PM is equal to work over the volume displacement, which is volume displacement is equal to V1 minus V2. V1 minus V2. So we use this formula is equal to 111,468.728 over 6 cubic feet minus 1.2 cubic feet. So, and you have to multiply it by 1 pound is equal to 144 cubic squared inch. Yeah. So the mean pressure is equal to 106. It is equal to 161.2684 psi. There, the mean pressure is equal to 161.2684 psi.